So far, we have seen vector value function. So vector value function. This vector value function thing, what it does is that it is just a function that sends a number to a vector. So a number goes to a vector, For example, I can have a function in terms of t, but the output of this function, the outcome of this function is going to be a vector. Like I can have vector 1, 2, 3 plus t times 4, 5, 6. So here, this is an example of a vector value function. My t is just a number, but once I compute this thing out, it's going to be a vector. Now, the next thing that we also talk about is a parametric equation. When we talk about parametric equation, what kind of happen is we have a number. But knowing this number, I can tell the values of many other numbers. So I can tell the value of many other numbers. In other words, I'm going to have many numbers that is dependent on this thing. For example, I can have a parametric equation in terms of t, and knowing this value of t, I can tell the value for my x, my y, and my z. For example, my x could be, let's see, 1 plus 4t. My y could be 2 plus 5t, and my z could be, let's see, 3 plus 6t. And this so-called vector value function thing and parametric equation thing, they kind of have to do with each other. In fact, the examples that I have here, they actually would produce the same 3D line. Now, the topic for this lecture is going to be about function of several variables now. So function of several variables. Here, when we have function of several variables, the opposite scenario is going to happen. Like in the earlier case, I have one number and that one number will determine many other numbers. But in function of several variables, what is going to happen is I will need to know the value of many other numbers to determine one number. Like in my pink case here, my value of t will tell the value of many other things. But when we have function of several variables, I'm gonna need to know the value of many things, like let's say w and x and y here. And that will be needed to determine the value of c. For example, I can have my z to equal to, let's say, w plus x squared minus 4y. Or I can write this as a function in terms of the function of w and x and y. And this is going to be w plus, let's see, x squared minus 4y. So here is how the function of several variables is different from the other two that we have talked about and how they fit in to the big picture. So let's do this next example here. So this is not that bad, by the way. So my function is going to send from r squared. So that means my function is going to have two variables, x and y. And my function will send these two variables, the value of x and y, into a single value here. So if I want to compute the value of this guy, I can just plug in 1 for x and 2 for y. So f of 1 and 2, this is going to be just 6 minus 1, plus 2 times 2. And that is going to be, let's see, 9. For f of 3, 2, that is going to be just 6 minus, minus 3 plus 2 times 2. This is going to equal to, 7. And the last guy, f of 1, 4, I can once again plug in 1 for x and 4 for y. And this is going to be, 6 minus 1 plus 2 times 4. And this is going to equal to 13. So here we can compute the value of the multi-variable function or function of several variables by just plugging in value. By the way, if I let z equal to this thing, so if I just write this equation as z equals to, 6 minus x plus 2y, I can rearrange this into, if I move my x and y to the other side, I'm gonna get x minus 2y plus z equal to 6. And we can tell that this is in fact just an equation of a plane, and that's kind of what we are looking at here. This plane is actually just the graph of the functions of several variables 6 minus x plus 2y that we have seen earlier.